In this video, we talk about amortization and sinking funds. So by amortization, we mean spreading payments over multiple periods. For example, if you have a housing loan and you may make periodic payments toward reducing your indebtedness to the lender, who charges interests at a fixed rate on the unpaid portion of the debt. Usually, you are required to repay the lender in periodic installments, and this amount is of the same size and over fixed term, so that the loan is amortized at the end of the term. And here the loan means the principal amount plus the interest charges. We may think of the monthly loan repayments R, let's denote them as R, as the payments in an annuity. And you need to recall that the present value of an annuity is given by P equals R times 1 minus 1 plus I raised to power negative n over all over I, where P is the original amount of the loan. Or the present value. Now the question is, how much should the monthly installment be so that a loan will be amortized at the end of the term of the loan? Now here, in order to determine this, we need to solve, let's call this equation or this formula star. We solve star for R. To solve for R, let me rewrite the formula here. R times 1 minus 1 plus I raised to power negative n over I. Now we solve for R. That means we divide both sides by 1 minus 1 plus I to negative n over I. We cancel these. So we get R equals P over 1 minus 1 plus I to negative n over I. And since we have a fraction in the denominator, we flip it. We get P times I over 1 minus 1 plus I to negative n. That means the monthly installment is given by R equals the principal times I over 1 minus 1 plus I to negative n, where I is R over M. R is the interest rate. And this M is determined by how many times we make the rate or the interest is compounded. So when we solve this, we got this formula that gives me amortization. This is called amortization formula, which gives me the periodic payments. Okay, now here this formula gives us the periodic payments R on a loan of P dollars to be amortized over n periods with interest charged at the rate of I, and that should give us the required formula. Now let's take an example of amortization. Here in this example, we are given that we have a sum of 50,000 paid over 5 years, and the equal installments made at the end of each year. If the interest rate is 8% per year and is charged on the unpaid balance unpaid balance, and interest calculations are made at the end of each year. Determine the size of each installment so that the loan, the principal plus the interest charges, is amortized at the end of the 5 years. So here we need to determine these numbers. 50,000, that is P. 5 is N. 8% is R. We need to find I. I is R over M. This is compounded yearly. That means M is equal to 1. R is 0.08. So I is 0.08. N is 5. P is 50,000. Now we use the formula to find the installment. R is P times I. P is 50,000 times I. I is 0.08 all over 1 minus 1 plus I. I is 0.08, or raised to power negative N. N is 5. Using calculator we get 12,522.82. This is the required yearly installment. We can visualize this process of paying yearly by constructing the following table. Here we have end of period, interest charges, we have payment made, we have payment toward the principal, and we have outstanding principal. At the end of the period 0, we don't have any charges here, and we have to pay the full $50,000. At the end of the first year, we have interest of 4,000, and that's because the 4,000 is because that initially the larger portion of the payment goes toward payment of the interest charges. Now the payment made, this is equal for all these years, the 50 years. So it's 12, we compute it here, it's 12,522.82, and the payment toward principal with the interest charges, we already paid, if we at the end of the first year, 8,522.82. So that means we are left with 41,477.18 at the end of the first year, this amount of the outstanding principal. At the end of the second year, the interest that we have to pay is 3,318.17, and the payment made is the same, 12,522.82, and then we take this off the payment made, and that means we paid 9,204.65 toward the principal, and we are left with 32. We have to pay, or what's left from the outstanding principal is 32,272.53. At the end of the third year, we have the interest of 2,581.80, and we still pay the same amount but with this interest rate, if we pay this amount, 12,522.82, that means we paid 9,941.02, and the outstanding principal is 22,331.51. And here we continue. The fourth year, the interest will be 1,786.52. The amount, the payment made is 12,522.82, and that means we paid 10,736.30 toward the principal, and what is left is 11,595.21 of the outstanding principal. The last year, the fifth year, the interest becomes 927.82. The payment made is the same, and we are actually here paying 11,595.20, and the what's left here is just 0.01. This is supposed to be 0, but because of round off error, we get this amount. Now another example. In this example, we have two people, Teresa and Paul, purchased a house 10 years ago of 200,000, and here they made a down payment of 20% and of the purchase price and secured a 30-year conventional home mortgage at 6% per year compounded monthly on the unpaid balance. Unpaid, this is one of the key words here. So the house is now worth 380,000. How much equity do those two guys have in their house now? I mean, after making 120 monthly payments. So here let's find first I is 0.06 over 12 because it's compounded monthly. This is M and this is the rate. So we have 0.005. N is M times T. M is 12 times T 30 years, and that gives 360. Now, since the down payment was 20% of 20,000 or $200,000, that means this is equivalent to saying that the the present value is 160,000. Now we find the monthly installments. It's P times I. P is 160,000. I is 0.005 over 1 minus 1 plus 0.005 raised to power negative 36n. And that's equivalent to, or approximately, 959.28. So they should pay this amount every month. Now after 120 months, we have 360, this is n, the original n, minus for the whole period, minus 120, and that gives us 240 months are left. I mean, we have to pay for these months. Now we find the present value here, 259.28. This is R times 1 minus 1 plus I is 0.005 to negative 240. Now n is, this is the new n is 240 over 0.005. Using the calculator we get $133,897.04. Now, in the question, we want to know how much equity do Teresa and Raul have in their house now. So we have 380,000 minus what's calculated here, the present value. The present value is 133,897.04, and this is approximately 246,103. This is just approximation of the answer, dollars. Okay. So this is how we apply the formula and we understand the amortization. Now the second concept here is the sinking funds. By sinking fund we mean we establish an account for a specific purpose at some future date. For example, a corporation might establish a sinking fund in order to accumulate sufficient capital to replace equipment that is expected to be obsolete at the future date. Now the amount here, so this is another application. So sinking funds, this is another application of annuity or annuity formula. Okay, so here this amount will accumulate by a specific date in the future. It can be thought of as the future value of an annuity. So we have, if you remember, for the future value of the annuity, you have S equals R times 1 plus I raised to power n minus 1 all divided by I. This formula gives us the future value of an annuity. Now solving for R, as we did for amortization, we get R equals IS over 1 plus I raised to power n minus 1 by solving this formula for R. I mean, divide both sides by this amount, by this expression. Simplify, you get this formula. So this formula gives us the periodic payment R required to accumulate a sum of S dollars over n periods with interest charged at the rate of I per period of time. So let's start with an example here. For this example, a hardware company has decided to set up a sinking fund for the purpose of purchasing a truck in 2 years. It's expected that the truck will cost $30,000 if the fund earns 10% interest per year, compounded quarterly. Determine the size of each equal quarterly installment the proprietor should pay into the fund. So here we are looking for the size of the installment. That means R. So we are looking for R. Now in order to find R is IS over 1 plus I to n minus 1. We need to find I is R over M. R is 10%, so it's 0.1 over M. M is compounded quarterly, that means 4 times a year. And that gives us 0.025. This is I. And what about S? S is given here. S is the 30,000 because here the keyword will this is keyword. It's expected that the truck will cost 30,000. That means this is future value. Okay, so this is $30,000. This is given. Now we apply the formula. But before that, we still need to determine n. N is number of payments. Number of payments is given by m times t. M is 4 and t is 2 years. So that's 8. Now we can apply the formula. R is I is 0.025 times S is 30,000 over 1 plus 0.025, 1 plus I, raised to power n is 8 minus 1. Using a calculator, we get $3,434.02. Okay, another example. We have an employee of a company is currently planning to retire in 25 years and wishes to withdraw 8,000 per month for his retirement account for 25 years starting at that time. Now the question is, how much must he contribute each month into retirement account earning interest at the rate of 6% per year compounded monthly to meet his retirement goals? So we need to find R. R is IS over 1 plus I raised to power n minus 1. Now we need to find I. I is R over M. R is 6%, so that means 0.06 over M. M is compounded monthly, so that means M is 12. Simplifying this, we get 0.005. Now we need to find N. N is M times T. M is 12. T is 25. This is T, 25 years, and that gives us 300 installments or payments. Now what is R? We need to find, okay, we need to find R. So R is IS over 1 plus I raised to power n minus 1. Now how to find S? Now in order to find S, S is the amount of the sinking fund that's needed to be accumulated to fund this employment retirement needs. So that means we need to compute this future value, R times 1 minus 1 plus I raised to power negative n over I. Now R is 800. R for the future amount, we consider R is 8,000. So this is R that enable us to find the future value. It's 8,000 times 1 minus 1 plus 0.005, that's I, raised to power negative 300, all over 0.005. Using the calculator, we get 1,241,654.91. This is in dollars. Now we want to know how much the employee should deposit into his account to meet the retirement needs. Okay, I mean to meet the accumulated amount, the 1,241,654 241,654.91. So in this case, we apply R. R is the periodic payments taken off or taken out. Now this is I times S over 1 plus I raised to power n minus 1. Now I is 0.005. S is, we already computed here, it's 1,241,654.91, all divided by 1 plus I raised to power 300 minus 1, and that's approximately 1,791.73.